Welcome to EDU World Space.
In this question, we're told that 10 days after it was launched towards Mars, the Mars Climate Orbiter was 2.87 times 10 to the 6 kilometers from Earth and traveling at 1.2 times 10 to the 4 kilometers per hour relative to Earth. At this time, we are asked to calculate the spacecraft's kinetic energy relative to the Earth, as well as the potential energy of the Earth spacecraft system. So to start off, let's tackle the kinetic energy. And of course, we are going to use the regular formula 1/2 mv squared. And the only problem with this is that, this formula assumes standard units. In order to get joules out, we do need to use meters per second for our velocity. So let's do a quick unit conversion over here. So we're starting with 1.2 times 10 to the 4 kilometers per hour. And we need to multiply by a couple conversion factors here. So the first one, we want to get rid of kilometers. So I'm going to put that on the bottom. 1 kilometer is the same as 1,000 meters. And then I want to get rid of hours in the denominator. So I'm going to put that on the top, 1 hour. 1 hour is equal to 3,600 seconds. So that goes on the bottom. So I need to multiply by 1,000 and divide by 3,600. And that gives an answer of 3.33 times 10 to the 3 meters per second. So now that I have my speed in meters per second, I can go ahead and plug everything in for my kinetic energy. So the mass of the spacecraft was given as 629 kilograms. And we'll plug in that speed we just found. And so the final answer here, once you multiply that out, we get quite a large number. It's 3.49 times 10 to the 9 joules. Or you can also choose to write that as 3.49 gigajoules if you would like. So this is our final answer to part number 1. And then we also want to calculate the potential energy of the Earth spacecraft system. So to do that, we're going to use the potential energy formula. So the two m's represent the mass of the Earth and the mass of the spacecraft, and the r represents the distance between them. And everything is pretty much in standard units. We'll just need to do a quick conversion to meters for the radius. So let's just sub everything in here. We've got 5.97 times 10 to the 24 kilograms for the Earth's mass. And then, And then for the separation between the two objects, we have 2.87 times 10 to the 6 kilometers. If we want to convert that to meters, we need to multiply by 1,000, so that becomes 10 to the 9. So once you plug that into a calculator, you'll see we get a final answer of negative 8.7 times 10 to the 7 joules, or you can also write that as negative 87 megajoules if you prefer to use prefixes. So this is our final answer for the second part.